Hello friends, welcome to my channel Civil Smart. Today we are going to design a short circular column with axial load, and the condition is when the column size is not known. In the previous lecture we have designed a circular column short axially loaded where the size or the dia of the circular column is known. So firstly we will find in the first tab the column dia, right? We will find the column dia, how much the dia is required for the column. Next we will check for the short, it's a short or long column. Definitely it should be a short column because we are going to design a short axially loaded column. Check for minimum eccentricity as per the IS code, we will check, right? Next is the area of the steel required, number of bars required in the circular column, it will be calculated. Finally the helical reinforcement, that is the spirals, we need to go for the spiral in circular column, so it will be calculated, the pitch and the dia of the steel. So let's start. We have to put our data in these pink cells only. So unsupported length is given as 3 meter, right? We have two conditions generally. If the column is restrained against rotation in both the direction, then L effective given by this 0.65 L, that is 1.95, or if the column is not restrained against the rotation, effectively held in position and not restrained against the rotation, so L effective is given by 1 L. Generally two conditions are there, right? This is our condition, the column is effectively held in position and not restrained against the rotation in both the direction, so we will take the L effective as 3, right? So FCK in this case is M25, and for M25 we have to design, and FY is 415. So clear cover in the case of the column is 40 mm, and the load for which we have to design a circular column is 1000. So ultimate load is calculated by multiplying 1.5, that is 1500. Now we have to find the diameter of circular column. So if we are assuming E minimum is less than 0.05 d, because this is the condition when the minimum eccentricity as does not exceed the 0.05 times the lateral dimension, that is d, then we have to use this formula, Pu equals to 0.4 FCK AC plus 0.67 FY ASC, right? So factored load is, we have calculated 1500. Now we have to assume the percentage of steel. So percentage of steel in case of column, we all know that it lies between 0.8% to 6%. So if we are assuming 1%, so you can see that ASC will be 0.01 of AG. 1% means 0.01 times of AG. AG is the gross area of the circular column, right? Now we already know that for the circular column with helical reinforcement, this PU is 1.05 times PU for square or rectangular column. We all know that this formula. So area of concrete in this case AC, area of concrete is AG minus ASC. We have already taken ASC is 1%, 0.01 AG, so AC will be 0.99 of AG, right? If you choose 2%, then you can see that this will change, 0.02 AG, and AC will be 0.98. So 2% of ASC, area of steel, so area of concrete balance will be 0.98%, right? So we have chosen 1%. So we can see that D required is already been calculated as 379 mm, right? So by this formula, if you put all these values, AG minus ASC is 0.99 of AG and ASC is 0.1 of AG. So this has been calculated. AG required is calculated is this mm square. So AG is pi by 4 of D square, and D required is calculated. So if we choose 380, then you can see AG provided will be this much. This is a short column, but this is not satisfying E minimum by D condition, right? 0.053. E minimum by D should be less than equal to 0.05 by this. When the minimum eccentricity does not exceed 0.05 times the lateral dimension, right? Then only you can choose this formula. Okay. In our case, we have to increase our dia. If you are choosing 400, you can see that AG provided is this much, and this is a short column because L effective by D is less than 12. Okay, check for minimum eccentricity. We already know that E minimum is L by 500 plus D by 30, so this is 19.33. we have to take some subject to a minimum of 20 mm, so you need to take the maximum of these two values. This is 20 mm, and E minimum by D D we have chosen 400 mm, so this is 0.50. If E minimum by D is less than or equal to 0.05, then it is okay. Otherwise you have to increase the dia of the circular column, right? So move on to next step, ASC required. Now we already know that ASC is 0.01 times of AG. We have, because we have choose 1%. So this is ASC required, mm square. Minimum AST is 0.8% of AG. So take higher of the value AST required. If we choose 16 mm dia, so 6.25 numbers are required. We have to go for the even number, so we will take 8 numbers. So 8 numbers required of 16 mm dia. So percentage of steel is 1.28. That is okay, right? For helical reinforcement we have already explained in the next previous video. So clear cover is 40 mm. We have chosen core dia. This is the core dia is outer reinforcement to this reinforcement of longitudinal bar, right? So D minus 2 into clear cover 320. So area of the core is pi by 4 DC square, right, minus AST provided, because we have already provided these bars, right? So we have to deduct this to get the area of the core. So assuming pitch P, then volume of core will be area of the core into P. This is the volume. Dia of the spirals, if we are choosing 8 mm, so you can see that volume of the spiral has been calculated by this formula, pi by 4 into dia square into, this is the circumference, pi into core dia minus this dia, right? So by this formula given in the IS code, the volume of the helical reinforcement divided by the volume of the core should not be less than 0.36 Ag upon AC minus 1 FCK upon Fi. So you can see the pitch P, we have calculated P should be less than 48.47. Now the limits for the pitch is, maximum pitch is should not be greater than 75 mm, P should not be greater than 53 mm. You have to take the minimum of these values, 53 mm, and P should not be less than 25 mm, and P should not be less than 3 times of dia of the spiral. So this is 25 mm. We have to take the maximum of these two. So you need to take from these three values, the minimum pitch will be 45 mm we can take, right? So 8 mm, 45 mm, center to center will be the pitch. So we have designed, this is the design summary. The dia we have find, number of the bars we have find, right, 8 numbers, 16 mm dia, and the spirals is for 8 mm at the rate 45 mm. Now if you change according to your condition, if you change the load up to 1500 and the unsupported length is 3.5 meter of the column, then you have to take the L effective as 3.5 meter, 3.5 meter. And you can see that the D required has been changed. Now you have to go for the higher dia, that is we can take 480, right? You need to check for the short column, okay, axially loaded column, because E minimum by D is less than 0.05. ASC required, now 9 numbers are required, so we will go for the higher. Now the 10 numbers are required because we have increased the load, so 10 numbers are required. If you change for the dia, then 8 numbers, 20 mm, 8 numbers are required, right? So you can change accordingly. Helical reinforcement, you can see that if you are choosing 8 mm dia, so 49.35 is required. So this is okay, 45 you can see, because you have to choose the lesser value. 49.35 should not be, it should be less than 49.35. Maximum pitch is 67 and 25, so you can choose 45 mm. So this is the design summary. So friends, if you like this video, please subscribe the channel for more design videos, and if you want this Excel sheet, please WhatsApp me or mail me on my mail ID, and thanks for watching.